All right, so we're going to talk about Caesar's cipher. Let's get idle going. So the idea behind Caesar's cipher is that every number has a numeric value, right, called its ASCII value. And its ASCII value is how it's encoded in memory. So what we need to do is we need to figure out what those numeric values are, right? Just so we can kind of visualize. So like, if we were going to, say this is our input string, right? I'm going to call it S input for input string, right? And I'm going to just type in ABC hello. Well, let's just see what those numbers are, right? So we're going to write a little for loop for character in S input. For every character in S input, let's print that character and what's known as its ordinal value. Right? Like that. Let's see what that is. We'll just see those numbers. Just like that. So A is a 65, B is a 66, C is a 67, and we could see where those came from if we went to ASCIItable.com, right? Where an A is a 65, a B is a 66, and a C is a 67. And so in Caesar's cipher, we shift them by some value. Like if we were going to shift them by 1, an A would become a B would become a C. So let's play with that. Same business, right? I'm just going to print them out here. But I'm going to print out the ordinal value, just +1, just to see what it looks like. Getting a good feel for it. Right? 66, 67, 68 instead of 65, 66, 67. So this +1 needs to be a variable, right? We need to ask the user for the shift value, right? So we're just going to do this. What's the shift value? It's the int of the input. We ask them a question. And that's what we add, right? All right. So let's shift everything by 10, right? Alrighty, so we get up to 121 here. Maybe that's too big, right? Maybe that goes off the edge of the ASCII table. So yeah, the ASCII table, as far as printable characters are concerned, ends at 126. We never want to get more than 126, right? Because otherwise we're printing out, these kind of weird characters. So what we need to do is if we get past 126, we need to subtract a number so that we can get back down to 32. And what's the difference between 126 and 32? That's just about 94. I think that's 94. So we didn't get past it, but we could have, right? What if we'd entered a shift value of 20? Then we would have gone past the edge. Or we can kind of fine-tune our estimate here, right? If we type in a Z and we shift by 1, 2, 3, 4, 5, then we want that to kind of wrap around back to 32. Maybe I got the wrong number, right? 127 to 32. That's not 94, that's 95. So let's take a little bit more care about what we're doing here. We need to build a new output string, a cipher string, right? So this is our plain text. And this is going to be our cipher. Maybe we could even rename the variables to make that clear. So this is the plain text, the original text for every character in the plain text. Let's just print out the cipher. Print out that character. We ask for the shift value. Now we need to build a new string that has been shifted. So the new string needs to start off empty, right? I mean, we got to start from 0, right? And then we're going to start adding characters to it. So for character in plain text, colon, let's get the ordinal value of it, right? Value is equal to ORD character, right? And then let's shift it. So we got to add our shift value to it. Value plus equals shift. But if it's too large, we got to subtract 95 from it. So if the value is greater than 126, it's a problem, right? Or was it 127? Let's go look. 126. If it's greater than 126, we need to subtract 95. Get it back down here. Okay. So if it's greater than 95, we're going to do value minus equal 95, right? But what if we had shifted a negative amount, right? What if somebody had been crazy and typed in a shift amount of -10, which is legit. So we need to make sure also that it was not less than 32. So if the value is less than 32, we need to add 95 to it. Whoops, that was supposed to be elif, excuse me. Elif values less than 32, and we're going to add 95 to it. Plus equals 95. And so kind of with our for loop here where we were printing out the character and the ordinal value, we need a new character, right? We have this character, but we need an enciphered character, right? So we could call it char2, and we need to convert that value back to a character. And we do that with the chr function. There we go. Now just like we did up here where we printed out the character and the ordinal value of the character, let's print out character 2 and its ordinal value. Just see what it looks like after we shift it by 1 or shift it by 5 and see some wraparound, right? So ABC, what is your shift value? I added 5, so 65 became a 66, right? Excuse me, 65 plus 5 is 70, and so A became an F, right? A, B, C, D, E, F, that's 5 characters more. Let's put a Z in our input string, and of course we really want to ask the user, right, for this data. So we're going to do an input in the plain text. I'm not going to do that. You can do that. All right, so the Z plus a 5 became greater than 127, so I had to wrap around, but we haven't done that yet. So let's shift it by 5, and the first character wrapped around and became a 32. And what's a 32? It's just a space, but past that there's some punctuation and stuff, right? All right. Now we need to add that new character to our string. And we really don't need to print these for our final thing. You're going to want to comment these out, right? Maybe we could even add the word debug to show that these are just intermediate things, right? And they're going to need to get commented out eventually. But we do need to add that character to our string, right? So cipher plus equals that new character. And let's just print it out, right? Print out. Let's print out the original text or the plain text, right? And then let's print out the cipher text. And so the original text was that plain text variable, not pain text, because this is a real pain. And this is the cipher text. All right, so what's the shift value? 5. And so here was the original text, right? That, and here was the cipher text. let's change it back to ABC because it's real easy to spot. I mean, let's change it back to a shift value of 1 because it's real easy to spot ABC becoming BCD. So run it again. What's the shift value? 1, right? So ABC did become BCD. So that's working. Now the other part of this was to come up with a cipher where it increased by 1 each time, right? So where we just didn't add 1 to each one, but where the first character might get a 1 and the second one might get a 2 and the third one might get a 3 and so on. So if we're going to do that, the shift value might have to increase by 1 each time, right? We might need a shift plus equals 1. So that it starts off shifting at 1, but then it shifts by 2, and then it shifts by 3, and so on. Let's put the ABC back at the beginning of it because it's going to be real obvious if that's what it is, right? So ABC. Right, so shift value of 1, and A became a B, right, because that's 1, A to B. B became a D because that's 2. C became an F because that's 3. All right, so I'm going to delete that because that's not part of the original one. But that's how you do it. That's what you need to do. And so how would you reverse it, right? Well, you would just take that shift value and make it negative, right? And subtract that much. Or you could just, you know, say minus equals shift. That's not going to work so much with that cipher plus equals, you know, where we add 1 to the shift each time. But this should get you a good start, right? So when you shift it for enciphering, it would be plus equals shift. And then when you take that string cipher and you want to decrypt it, you're going to use a minus equals shift, right? Because you got to get it back down to its original values. So it'll be another for loop, right? For character in cipher, get the value of that character, subtract the shift from it, still do this kind of stuff, and then add that to a new string. You would not add it to cipher, right? Because then you're kind of erasing cipher as you go along. All right, I hope that helps. Hope that helps.